be presenting on generative AI in creative fields. I'll be talking about what generative AI is, how it is used in music industry, art, literature, everything. What are the ethics about it? Is it right or wrong? What should be the regulations that should be enforced upon it? Okay, so let's begin with the basic definition. Generative AI basically helps us humans create new content, but it's trained upon existing content. So it technically still mimics a lot of the art style or the patterns that we humans use. Some common examples are ChatGPT, Sora, which is the video, text-to-video generator of ChatGPT. There's Stable Diffusion, all other online generative AI. All right, a quick history. So chat bots were kind of first launched in 1961, which is the first chatbot that was launched was Leela. I'll talk about it a bit more in the next slide. But basically, it was, you ask it a question and then in response, the answer is basically a question back to you. So it doesn't understand what the question is. It just says, if I am X, then why are you X? And in 2014, there was a major breakthrough with GANs. And I'm going to talk about GANs later on and diffusion models and everything. And then in recent years, large language models have popped up, like ChatGPT, Anthropic's Claude, Gemini by Google. So, okay, Eliza was, like I said, sort of a Rogerian psychotherapist. So if you ask a question like, is something troubling you, and or at least ask you a question, and then you say something like, X is the same thing, and then what is the connection do you suppose? So it's just, it's not understanding what you're asking, it's just a response to like variable change. Okay, we're going to be talking about how AI transforms design, music, writing, and we sort of delve into what models are better for each creative field, and talk about some copyright issues with it. The three main fundamentals of a good generative AI model is that it should have high quality samples, so it doesn't generate bad images or bad videos. They should still be presentable and align with what we see in real life in a way. And it should have good mode coverage diversity. What it means that if your data set is very heavily biased towards a certain subsection of society, the generative AI models should still be able to train it on the minorities. So for example, the data set has 80% young faces and 20% old faces. A good face recognition model should be able to identify old and young both. So and the last thing is fast sampling. A lot of live image editing and video editing requires live interaction and back and forth. So the generative AI has to be pretty quick. And sorry, just one thing. Most of the current models can only handle like 2 things at once, and not everyone can satisfy all 3 requirements cohesively. All right. The first type that I'm talking about is diffusion models. So how they work is basically a 2-step training process in the latent space. The latent space, let me define it first. It's basically an abstract compressed representation of data. So for example, how we humans view people, right? Someone has blue eyes or black eyes, and someone has a round face or some other face. So the data space defines your high-level features in a very abstract representation form. So the first step of diffusion is called forward diffusion, where you take an image sample and then you progressively add Gaussian noise to the sample, so it becomes pure, no noise at the end. And then for reverse diffusion, it goes from noise back to a newly generated image by using the same latent space or the abstract representation. So the image is not the exact same, but it's more of shares the same features with the original image. There are better than variational autoencoders, which I'll talk about in the next slide. And although they're slower than them, but they provide a much higher quality output. And there are a lot of papers that tackle some of the limitations on diffusion models in recent years that have popped up. And some of these papers also talk about attention mechanisms. So attention in generative AI basically means you're focusing on a relevant part of the sentence. So if the sentence is, so if the cat chased the mouse because it was hungry, and your question was who was hungry, so the attention guides the model to focus on things like cat and mouse and not words like the or something. So it gives more weight to those words. So like I said, data, you start the clean image, you do a forward diffusion process, it becomes noise, but you add Gaussian noise in every step, and then you regenerate new image. Variational autoencoders, sort of in an abstract form, a similar idea, but in this case we use two neural networks, the encoder and decoder. The encoder called the recognition network, so when it has an input, it converts it into a smaller representation, kind of like how diffusion model work. And the decoder uses that compressed representation to construct a new image, and just by also disregarding any irrelevant information. A lot of current softwares like Google, Spotify, and Netflix use autoencoders for like video generation or images, how they store images in a compressed form, so it doesn't take up much space, and then you can still get the good quality image back by running it through a decoder. And then Spotify does it for music streaming and everything as well. So yeah. Lastly, I'm going to be talking about GANs, and we'll talk about transformers a bit later. But so GANs, they basically consist of two things: discriminator and a generator. So a generator, you can think of it like someone who is trying to fool the discriminator, and discriminator is trying to catch what's generated by the generator is real or fake. So the training loop that basically goes is like the generator creates fakes, and the discriminator has a sample of both the real image and the fake images, and it basically tries to identify what real images are fake and what fake images are, what real images are real and what fake is fake. But if it doesn't do that, then it's penalized. So a quick example of the training loop. So in discriminator training, like I said, it takes a real image sample and also a sample that's generated by the generator, and then it's gone to the training loop. While the discriminator is training, the generator cannot be trained, it remains constant. And it outputs basically a true or false value, or something like, is this image a real or fake? And based upon that, it determines the loss, and its aim is to minimize the loss. So it does back propagation, updates the weights of the neural network to maybe better identify the generator. And in generator, you do the similar process, but in this case, you keep the discriminator constant. So the generator first gets a random input, a noise basically, and it creates a random image sample from that noise. The noise is usually sub-Gaussian. The discriminator basically says if it's true or false, or if it's a real or fake. And based upon that, if the generator was able to successfully fool the discriminator, it wins. And if it doesn't, it loses, and it's got to retrain its model.
I'm going to discuss about extreme image generation. Here we are going to discuss about the top AI text-to-image generators. Basically, the text-to-image generators are nothing but in ChatGPT we will ask like generate an image. So that's what one of the examples of text-to-image generators over there. So we are discussing about the top AI image generators in the market right now, and how does it works, and what are the pros and cons of text-to-image generators. So the top AI image generators were in the market, in existing market, were like DALL-E 3, which was an OpenAI source, E3 is the version, like updated version of DALL-E E model, and whereas the Midjourney and Adobe Firefly and Stable Diffusion and Ideogram. DALL-E 3, as I said, like it is an open AI model, and which was an high quality driven with prompt driven source. If we enter a prompt, we can receive an high quality image from it, which was directly integrated in ChatGPT. And after the Midjourney, it was used for like stylistic and artistic images. It was known for basically, and where Adobe Firefly, which was integrated with Adobe, and Stable Diffusion, which is an open source model that is used for like for control customized images, which was mainly used for customized images, like Stable Diffusion is used for. And whereas Ideogram is used for to get the text in the images, like it mainly focuses on the text in the images. So now, like, how does a image generation works? That too, we mainly focused on DALL-E E2 version. So in this, it involves three different processes, like three different models, like clip and prior neural networks and decoded neural networks. Clip is nothing but contextual learning image pre-processing. A contextual learning is nothing but like it gathers the data and it will segregate whether this data is related to the query he asked. It just performs test embeddings. Clip performs test embeddings in it. So that and after the text embedding is created here, it will transfer to prior neural network, and it will convert the text embeddings into image embeddings. And after that, the decoder is nothing but an unclip. It will do the exact reverse of what clip does. It will directly do like converts the text in like image embeddings into the exact images what he was thinking to do here. Here you can see like we had given a text like as a corgi playing a flame-throwing trumpet. So this is what clip thoughts from the image. Like it is mainly these like image generators mainly work on the data which was already available over there. So it will gather those data and it will create a new image, like a samples of images which were what is the prompt given. Based on the prompt he given, it will generate a new image from the existing images. So this is the existing image which was given by the clip, and after the decoding and prior everything done, this was what we got with the what we say like with the enhancing the image, by enhancing it and everything, by adding the other images into it, by compressing into it. So this is what we did. This is how it works basically, like DALL-E 2, with these three models. And after that, if we there is an API for OpenAI. OpenAI has given us an API which, if we want to create a software or if we want to create a web application, we can use this. Like we can use OpenAI, which is a Python library. By using this, we have like three methods, as I said, like creating an image with a text prompt, create edits to an existing image based on a new text prompt, and create variations of existing image. Here I had given a prompt like a stained glass window depicted a robot. That too with an n is equal to 1, which is the n refers to as the number of images we were asking for, whereas the size refers to the size of the image, and based on the prompt it will generate an image for us, and we can print the image basically. Basically I haven't printed it here. So this is how we can use this OpenAI library in our, what we say, like in our web applications if you think to use these text to image generators in it. Yeah. Here controversies basically. In this, we all know the pros of the text to image generators, like how it can be used in whatever ways. But if we mainly focus on what are the cons that were included with AI. Like a lot of nowadays we can see there is a deep faking and everything, and copyright and intellectual property issues, dependency and pre-trained issues. Sorry, like as I said earlier, like if if we ask for a prompt, like if you ask to generate any image, it will directly check for the images in the existing data, and it will create a new image based on that. In the same way, as I said, like dependency on pre-trained images. So it will directly depend on the datasets which was available in the training model, and it will create an image. So there is always a big chance of bias on it. And the other one is challenges in generating realistic human faces. And if we ask to generate a face to a GPT or anything, it will we can see there is an issue with lips or eyes and everything. And even the size, I had included a picture of fingers over there. It shows like if we ask to generate a hand, it will show the length of the fingers were pretty high in it, pretty large. And regarding the deepfakes, in March 2023, there is an image where the former president, like Donald Trump, is got like fake arrested in it. Some media says it was true, but it was a deepfake image generated by an AI. So these are the things which was like that can that provides misinformation to the society by using AI. Thank you.
I'll be discussing uses of generative AI in music composition now. So I'll go over a brief background, how it works, how it's used, and the question of ethics. So I wanted to start off with kind of this vague definition of algorithmic composition, which just means the process of basically trying to take human intervention out of the music creation process. So we've seen this in music creation throughout history, really, where people have been trying to, I guess, enhance creativity by taking humans out of it a bit. And we see a foundation for this just at the beginning when the Greeks built their music system off of mathematical properties, which kind of started the abstraction music theory. And you can begin seeing, the algorithmic nature of music. One example of, musical techniques that are algorithmic in nature is canonic composition, which is when someone sings and then like 4 beats later someone starts singing the exact same thing. So we kind of see how the algorithmic nature of music patterns can be exploited for eventual generative AI usage. So I'm ready to. This is a quote from an early computer scientist just in the 1820s, and I included it just because I think it's interesting that people have really been thinking for a while how the machine can be used to create and generate music to really complex degrees. So there are different ways that today the computer can assist us in music composition. There are stochastic composition programs which introduce randomness to music composition process, also rule-based programs, and these are things that can also be implemented in artificial intelligence, which is, of course, the use of AI methods to generate new compositions. So how it works, I found a piece of literature that discussed some common generator architectures that are used for generative AI, specifically for music composition. Of course, we discussed VAEs earlier, and transformers are also a popular model that have been successful in AI-generated music systems. We see them used in OpenAI's MuseNet, for example, and then also Magenta's music transformer. They're also an encoder decoder architecture, like what we discussed earlier, and they also utilize the attention layers that we were discussing earlier as well. Also for VAEs, they're very useful for generative music or generative AI music composition because of how we discussed earlier, can be used for the raw audio compression. So how it's used today, there's still a heavy component of humans actually working with the machine to actually create music probably refine it. And I have some good examples, I think, of like successful applications of generative AI for music in the next slide. So one example is the Tokyo 2020 Olympics theme song. So the Olympics committee at the time wanted to implement artificial intelligence in the ceremony, and they did so in a couple different ways, which is a pretty interesting read. But one way that they did it was by using AI to create the beat for their theme song. And I think that this is just a really good example of humans still being involved in the process, because of course they had to select the data samples that were being used. So they focused on songs or sound samples that included themes of sports, Japanese culture, to actually get a result that they liked and wanted to represent them for the ceremony. Another example is the finishing of Beethoven's Symphony. So when Beethoven passed, he left behind just a few notes for 10th Symphony, and people have always wondered, like, oh, what would it sound like? So in 2019, a group of music experts and also music technology experts got together kind of to push the boundaries of AI technology at the time for music generation, and challenge it with this idea of completing his symphony. So I think this is also a really interesting example, because not only did they train the model with Beethoven's music, but they also trained it with his notes that he left behind for finished symphonies. So because they wanted the model to learn his creative process, not just stuff he had already done. So I think that's a great example as well. And finally, I wanted to get into the question of ethics. This is a very pressing topic for the application of generative AI for the arts. Of course, there's questions about copyright, who should be credited for music that's made with AI in the process. There's also the question of consent. I'm sure we've all heard like examples of music that has used AI to like change the sound of the voice that's singing it. So there's a question of like, is that right? And then also the discussion about creativity and artistic value. Yeah. So I have some examples. One of them that I wanted to talk about, earlier this year, Taylor Swift released an album, and she released the names of the songs before she released the album. So someone had taken the name of the song, and they asked an AI model to create the song using what they knew about her previous work, and then just the name of the song. And then they released it on TikTok. So that's how I knew about this, because it got really popular on TikTok. Later, when she actually released the song, people were like, oh, I actually really liked the AI version, which is just, to me, it kind of starts an interesting discussion. And you can go to the next slide. People like the song so much that the original creator, that's something we need to talk about, who had prompted the AI to create this song, actually ended up publishing it on Spotify. They changed the name of the title, and they changed like a few of the words, but it was the AI song, and he released it under the same UC. It just says Max Lange. So I think this is just something that is kind of food for thought. Like, is it fair to consider a song written and produced by someone if AI was used in the process? Also, we saw on the previous slide, like, people were comparing these two songs, but is that really fair to compare a song that was created by AI to a song that had human creative thought and work put into it? Like, are those really unequal comparison grounds? So with the theme of copyright, so I think right now you can copyright songs where AI was used in the process. You can't copyright a song that AI was just used and you didn't change it or flip it or find it. But you're supposed to disclose that when you try and market for copyright. But record companies are, of course, a bit concerned about this, because when models are trained on sound samples that include works from their artists that they're signed with, they're concerned about that being exploited. So I think it's just an ongoing legal issue that we are seeing in real time. And then also, finally wanted to touch on consent. So again, like I talked about earlier, we've heard, if you guys have heard like clips of songs where maybe it's like a One Direction song, and then you hear Elvis Presley singing it, and you're like, oh, this is kind of cool. But also it's kind of weird, because you're like,
well, Elvis Presley couldn't consent to that, and also will never be able to consent to that. So Tennessee wanted to address this, and they were the first in the country to address this with a law where for AI, generative AI music, you cannot use the voice of someone who hasn't consented. And it makes sense that Tennessee would kind of lead the country in this with how important Nashville is to the music industry. But I just think that's a great example of how the government's starting to catch up with the use of this in arts.
Okay, I'm going to talk about natural language generation and type of research. I'm going to talk about how this works, some pros and cons. I'll mention some real life examples and then talk a little bit about the future of technology in literature. So first, briefly, I want to talk about how natural language generation is a small component of NLP. Natural language generation is the ability of the computer to generate human text and speech. Natural language understanding is the ability of the computer to understand human text and speech, and both of these combined make natural language processing, which is the overall umbrella term for how computers understand, interpret, and use human language. So there are 6 steps to natural language generation. The first one is content analysis, which involves filtering the data and identifying important content. This is where the user puts the prompt with the data. Second step is data understanding, which involves interpreting this data, identifying patterns, and putting it into context. This step is the one that uses machine learning algorithms the most. The third step is document structuring, which is creating document plan and narrative structure. Fourth step is sentence aggregation, which combines the relevant sentence to summarize topics. Fifth step is grammar structuring, where the AI applies grammatical rules to create natural sounding text. And the final step is the output, where the AI formats and presents the output to the user based on the prompt the user provides. So natural language generation has a lot of benefits. It produces text at a very rapid rate, which increases the efficiency of the writer and the other. Also, the AI can create very personalized narrative, so you can create the stories based on what the user or the individual preferences. And also expands creativity by providing new ideas and introducing new narrative topics. However, there are some drawbacks. First, it lacks the depth creativity of humans. AI can only mimic, it does not produce new meaning. There are the ethical concerns, which basically said it's the text produced by this AI, who owns it, and there's the loss of human touch, which has to do with emotions that the other outputs when creating this text. Here are some examples. The first one, the Unbloody series, is poems written by AI in collaboration with others. The second example is The Day of Computer Writes a Novel. This AI novel actually was introduced into an award and it passed the first qualifying round, which basically means it passed its student test. The Philip Parker streak. This author claims he wrote over 1 million books using AI. It's a huge number. And then the last example is this web page. It has a lot of books completely written by AI, where even the cover is produced by AI. So looking ahead, we see that NLG brings a lot of benefits to literature. We still have to consider questions like if AI is going to be capable of writing award-winning novels, and who will own these novels. Either way, AI has the capability of reshaping literature, and it prompts us to question creativity in literature.
Fortunately, our other member couldn't be here, so I'll quickly go over AI in visual arts and fashion as well. In visual arts, there are like a lot of existing platforms that develop AI-generated art that have been trained on the artistic structure of existing artists. There are also projects like Google's G-Dream, which curates psychedelic photos or transformations of existing photos. So it sort of looks like you're in a dream, but it's basically a psychedelic version of it. And lastly, in fashion design as well, AI has kind of transformed the field a little bit. Such as they have virtual try-ons. So basically, your human model, they virtually like to show you how to like what you would look like if you actually bought this piece of cloth. So it saves a lot of time in the supply chain, because then you don't have to worry about a lot of missized products or something that's not working, or something that's in fashion and art. So you can evaluate a lot of things about fashion trends as well, and then it helps with personalization and influencers as well.
Good afternoon, everyone. I'll be talking about AI use in film animation and the game design industry. And we will be looking at some game design patterns. We'll be looking at particularly how the models that we have talked about today are used. And we'll talk about how the generation process works as to use the industry as well. So we'll first begin with talking about game design patterns. I found this particularly interesting because my undergrad used to study software design patterns for software engineering and construction. So when we're talking about AI use in terms of game development, especially with NPCs and whatnot, there's typically 9 models or 9 patterns, if you will. The first one is AI. The first one is AI is visualized, basically where the behavior of the AI is seen by the behavior. So I think of like, for those of us who grew up like with like 2000s, 1990s era like AI, with like the Legend of Zelda, where you know like distracted God or something. That's an example shown here. There's also the AI as role model, where we typically try to get a particular character or a pet, or a typical pet or character model, if you will, to act in accordance with player's behavior. So an example here is a game I didn't know existed. I think it's called God Black and White, or something to that effect, where basically you take control of the dinosaur, or dinosaur, and basically control the population. And then finally, there's the AI as trainee, where you wish to maintain as similar to a group of characters as possible in order to maintain success. An example given here is the game's Spy Party, where the player is tasked with being a spy at a party and is basically under threat of constant assassination and must remain similar to other characters. Next slide. And then of course there's also AI that is editable, where as the player can change the AI model of the system. So an example given was the first-person shooter, where a player can constantly shoot different weapons, different varying styles. You can modify the skills and natures of their statistics, or their player statistics, in accordance with their actions. There's also AI as guided, where it typically operates in a pet-like manner, or in which the player controls various characters in order to maintain their AI, but also seeks to protect them as well. An example given, of course, is The Sims. We can also think like pet-based video games like virtual dog, virtual cat simulators, things like that. And then finally, there's the AI as co-creator. I was a bit confused a little bit when I first read about this one. When I heard co-creator, I thought of like original like third-person games where the models would follow your character around through the AI. And what it turned out to be was a co-creation platform where it's not so much a new game in and of itself, but the AI assists in the production process. The example I think today is like Unreal Engine's Metaverse, but we can also think of like earlier user-generated based games like Little Big Planet, basically where the AI assists the player directly to create content. Next slide. Then, of course, there's the AI as adversary, in which the AI controls opponents that seek to harm or defeat the player. Examples given here, of course, are Minecraft, and also think of any other third-person action games. This one was a bit interesting distinction I found. I didn't really know about this beforehand, but there's also what's called the AI as villain, where the AI controls an opponent, but unlike the adversary model, it does not seek to destroy the player, defeat the player, but creates a constant sense of suspense or tension, never actually defeating the player. An example given here is from the game Alien Isolation, where throughout the game an alien constantly chases the player, but never actually kills them. And then finally, there's the AI spectacle, where the player can manipulate or modify an ecosystem around their surroundings, their actions. An example given here is the 2000s era game Spore. We can also think of like No Man's Sky and of course Minecraft and other types. In terms of the generation process for game production, we mainly find that generative AI can both be used in the documentation phase, but also to seek communication between teams. Additionally, of course, video game development teams being a software engineering like any other, we wish to maintain our documentation to ensure that the legality of all of our work is understood by all participants, of course. So, of course, we have an example here of The Walking Dead Entities, where the creators of The Walking Dead Entities game, they had to maintain both the documentation of the ownership of the IP of the franchise itself, but also they had to maintain communication amongst their team in relation to game assets. They were able to generate said game assets, 3D assets with Project Nox, another AI product. And in doing so, they're able to maintain or improve the quality of their work as well. So here I found a very interesting case that kind of reminds me of personal work a little bit, where sometimes when we're working on a team of game developers, everyone has their own strengths. Some are more development oriented, some more artistic oriented. So a study was conducted with the use of what's called SketchArt. SketchArt is an AI model for production of two-dimensional animation sprites. We can think of these used for 2D platforms, RPGs, so on and so forth. The SketchArt model was used in the study to produce two-dimensional models for the team, but it was used mainly by the developers to communicate what they wanted in their game to the artists. And the artists would take that work, take it as inspiration, maybe have build on it, so on and so forth. And what the study found was that those who are not artistic oriented, those who are not creating the arts, developers actually gain more greater use out of the software to communicate to what they need from the art team, the software development team, than those who. So of course, we're going to talk about some of the models that we talked about today: the GANs, the recreational autocoders, the fusion models, so on and so forth. Mainly, we're going to be talking about how these models are used in the generation process of the video game film and animation industry specifically, not so much the internals that we discussed. So first, we'll start with the generative artificial network, where, as was previously noted, typically these are used to improve the quality of background assets, images, typically used in deepfakes. We can typically use these for generative assets within game development processes, or we can generate both three-dimensional and two-dimensional assets, typically for developers to use. As a matter of fact, I found one paper, I think, 70 assets were generated over the course of 6 hours, so it really cuts down the production process. It also improves the communications as good. Then we go to the VAE. By creating new frames of animation, we can assist in creating the animation styles that we typically would use as game developers, that once would be created individually in the process blender, let's say, or Apache or any other software. But it also kind of helps cut down the production process as well in terms of animation. One image I found actually was the use of a VAE model to play Mario Bros. Here we are given in variations of 1 to 4,000 epochs, differentiated by 1,000 respectively. That as the epochs grow, we see that it becomes more and more similar to normal gameplay. In terms terms of the diffusion models, like DALL-E, as previously mentioned, these also assist in the creation of arts, or not arts, but assets, through artwork. Typically, as noted, we use the noise, but typically we'll use these in various other models like DALL-E to assist in generating assets respectively. I guess we can go on to the next slide from here. And in terms of the transformer model, typically when we're in the game development process, sometimes writers, as a matter of fact, some of my friends who are also writers for a project we're doing, typically we may use AI to assist in writing a script. If we're having trouble, or if we're, let's say, stuck in a stage of writer's block, we're trying to set the story or setting. It can help us by aiding or acting as an aid to writers in the process of the story itself. It can also assist in the production of dialogue, scripts, which can also, once again, assist in the production process time. I guess from here we can go into the problem.
So I'll be talking about ethical and legal considerations that have usually popped up in recent years. So the first one is copyright and IP challenges. So there is currently an ongoing case between Stability AI and Getty Images, where Getty Images are suing the Stability AI company because they're using their images in their database to train their models without permission, basically. And there's also an ongoing copyright between New York Times and ChatGPT and OpenAI that I'll talk about later. And finally, creators. It's changing the job landscapes. A lot of creators are worried because their artistic style is also being stolen, and not just the artwork that they are doing. There's ethical concerns that can pop up as well, which is kind of similar to how the above challenges exist. So to tackle this problem, we need sort of a more transparency in the AI models. We want to know what they're using, what they have learning, which is kind of closed right now. Make it more open source, basically. And for future development, we would like some clear-cut legal frameworks, perhaps, that exist. But at the same time, for that to happen, we would have to assume that the government knows the intricacies, which won't be possible without transparency. A quick defense that a recent paper has published is called Glaze. So how it works is basically it kind of transforms the original artwork image in such a manner that the generative AI cannot use that image to learn. So what it does is, you can think of it like a finish on top of an existing image that doesn't change how we perceive it as humans, but it drastically changes how the AI model perceives the image. So for us, these two images are exactly the same, apart from a bit of a pixel change and everything. But for an AI model, these two images are radically different. Like, this is a wolf for us, that's not a wolf for the AI. So, and this can't be bypassed by a lot of methods. So like, you can't just take a screenshot of the image and hope that you kind of clip some pixels away from it or compress it. Glaze can effectively still defend the attack. There are a lot of ongoing cases and controversies. Just a quick fun thing that I was Magic the Gathering. If anyone has played that card game, there was a lot of controversies surrounding an AI generative model creating an artificial card. So that, like I said, the Getty and the Stability AI, and then a lot of lawsuits and stuff like that. Quick ongoing case, which is why New York Times is suing OpenAI for more than $1 billion in damages, because apparently it says that OpenAI have been using New York Times articles and bypassing the paywall for every article and just learning from that. And yeah, well, OpenAI says, well, we don't really do that. We have a lot of content reproduction, filtering, and everything. So it's a very dicey one. Can you go back? A quick thing, by the way, if you guys want to check right now, if you go to x.com or Twitter and you read their privacy policy, it will clearly state that any image that you upload on Twitter or X can be used by the generative AI to learn, unless you opt out specifically. So by default, it is on, which means if you just create a new account today and you don't know how it works or how you turn the setting on and off, your images are being used to train. And that's for almost every website, I'm guessing. Alright, I'm gonna be almost out of time, so I'll just quickly go over this. The future, so how can we improve generative AI? Currently, it works on a lot of specific models. So there's image, video, sound. We want sort of a multimodal generative AI that can do all of those things. Basically, sort of create a movie from scratch in a way that also has a plot and makes sense. Advanced reasoning. So from basic pattern matching, how it can understand causal relationships. If A causes B, what's the reason behind that and stuff like that, reasoning, and like how planning is done in robotics. And from imitation to originality, which is technically not feasible yet. Personalized AI systems as well, which have adaptive assistants for humans that is specifically trained for your specific needs and how you work as a human, how your day-to-day goes. Real-time generation and editing, that's still a work in progress. And I also watched the human AI collaboration, how AI can be a great partner in different fields. So, yeah, thank you. Any questions?
Any quick questions before we switch into team forming?
I was just curious if you guys learned in the GAN's training, if the discriminator and the generator models are trained like at the same time, or if they're, is that something that you guys?
No, so generator is trained at a different epoch than a discriminator. So when a generator is being trained, the discriminator remains constant, and for like X runs, and then after that, the discriminator gets a chance to train, and the generator remains constant. It goes back.
Sweet, thank you so much. That was awesome. We learned a lot about a lot of different topics. Now, we have